I think we can get started. It's now 5 already. Maybe we can get started with a demo first, then we can discuss more details about the things, especially I have put some item like default value. How do we support that?
So I will.
That's the biggest question for me right now.
I will share my screen. Oh.
I think she's probably switched to another one. Just a little bit of background. Huaxing is working on one of the demo, which uses Spark as a engine to try to integrate with current spec. And the REST catalog side will be a mock, which is only take the metadata JSON file without the REST endpoint. We can do the REST part a little bit later.
So like a in-memory catalog kind of thing.
Yeah, sorry.
Right. It's kind of mock. Go ahead, Huaxing.
Yeah, I have a new laptop. That's why I have to, set this up. I have to close this and restart.
No worries.
Sounds great.
Can you see my screen? Okay.
Yeah, I can see your screen.
So basically, I have a POC. In the POC, I implement REST UDF support, and then I kind of link this REST UDF support to the Iceberg Spark catalog, and then the UDF the support can list the function names from the REST server. And then when the function is loaded, it can fetch the UDF metadata JSON from the server. And then I will use it to register a temporary Spark SQL UDF. And then we can execute the Spark UDF. So let me show you the. Also, maybe I can choose the code. Let me. How do I share my IntelliJ?
You can probably share your whole
I should.
desktop.
Okay.
Right.
So can you see this okay?
Mm-hmm.
Can you maximize it?
Yeah, sure. So basically, I have a end-to-end test. So in the test, I will create a REST server. I create a REST server, and then inside of the test, I will just create the table first, and then for the I will cast this to the I will cast this catalog to a function catalog, and then I list the function. I list the function, and then I load the function. I will execute this. Maybe I'll just run it quickly. So in the catalog server, I manually just register two UDF functions. The two UDF functions are from Yufei's example. So one is from the add one. The other is for the fruit color. Let me show you the PR maybe. How do I?
Maybe we can go through the process how Spark get the messages and how Spark handle that register as a temporary UDF.
Let me see.
Yeah.
So,
Going over one of the JSON files would be cool.
okay.
I think I understand what the test did, and that looked reasonable to me. So fruits by color was a UDTF that returned basically a filter of that table.
Yeah. So basically, I have two JSON file, or both of this is JSON file are from rephrase example. So one is for the add one. So every time just a +1, and the other is fruit by color.
Yep.
And then in the open API in the text fixtures, I have so this is the existing file in the catalog adapter. For the list function, if the route equals the list function, I will create a list function response. So basically, I just I just add this to two function names.
Mm-hmm.
And then if the route equals load function, and then I will just load the function from the example from this two example. So this is for the server, the REST server. And then for the REST client side, do I need to make this bigger?
I can read it. I think it's fine.
Okay. So for the REST client side, I have a REST function service. So basically, for the list function, I will get this. So I will have a list function response. And also I have for the I have function. This is for the load function.
Mm-hmm.
So correspondingly, I have one of the list function class, list function response class, and the load response function class.
Mm-hmm.
So this is the REST client, and then on the here is for the Spark 4. So in my test.
Just 1 minute questions. Only Spark 4 can support that well, or Spark 3, 5 can support it as well?
Spark has supported function catalog for quite a while, so I think it should be able to support everything.
And also, I think the SQL UDF is only supported in Spark 4.
Oh, really?
Yeah, I think so.
Is that a Spark feature that we're taking advantage of?
Because for the SQL UDF support, I can just register the UDF using SQL. I will let me show you. So for the SQL UDF, I can simply do a Spark SQL and then do the create function.
Mm-hmm.
Yeah.
Yeah, I think the problem is when you register UDF, SQL UDF, only Spark 4 can support that, right?
Yeah, I think so. For our UDF support, it's only for the SQL UDF, right?
So I think this kind of gets into how we support UDFs in Spark. I don't think that we would want to run a create or replace temporary function using strings in Spark for the actual implementation, right? Because the implementation should behave more like a view, where I think we I mean, I'm not actually sure how it will work, but it seems to me that we would want to like load the SQL text for the thing and insert it into the plan, much like Spark is doing when it actually resolves the function that you're declaring here.
You're right. This temporary function is only for the POC.
Okay.
Eventually, we need to we need a permanent thing. But I think it's we will have the for the registration we want to use the SQL, right? Because this is the SQL UDF.
Yes, we do. Well, my point is that we shouldn't be registering with anything in Spark. Like the catalog is where the registration occurs. So Spark should be loading this UDF and saying like, okay, give me the UDF text, rather than having us create a name in some other namespace for the UDF. So I'm not sure how that works, but I'm sure we can grab Anton sometime and and make it happen. This is probably fine for now. We would likely want to have some sort of way of generating function names that, you know, allow us to have unique functions and use this path. But I think long term we probably want a different type of resolution.
Yeah, sure. Yeah, this is the temporary. The create a temporary function is only for the POC. Yeah.
Yeah, we might be able to just like parse the thing into either a SQL plan if it's a UDTF or a expression if it is a scalar UDF, and insert that expression in where the function was. That's what I would expect, I think.
Okay. Yeah, sure. I can change that later. So basically right now I just I plug in this this REST function to the to Spark catalog. So in the Spark catalog I will have the list function and also the load function.
Yeah, I think it's great that Spark already have the function catalogs interface, which is list and load. Both interface could be used when we implement this.
Yeah, this is the list function and the load function are from Spark function catalog. Yeah.
Yeah, as Ryan said, I think we probably needed to sync with Anton or TV's team because they are doing that, and see if we can avoid the rest the temporary function. Yeah, that part of me a little bit tricky.
Oh, okay. Yeah. Okay, I will think more about this. How to do that? How to do this?
Yeah. Also, I mean, there are other things here. Like we shouldn't be loading built-ins from Spark. Like this should just load our function if it's there, because Spark should already have resolved that the name does not identify a built-in function.
Okay.
Yeah, I think the other means the POC.
Yeah,
I think squashing enemy.
Yeah, it's not a big deal right now.
Yeah, discuss a little bit about the how all these property, if there's rule, how Spark enforce that, and if Spark does not support a certain feature, we can fail fast. Or I think if that's a rule, we have to fail fast. If it's a hint, we just ignore that. These things are maybe not a part of POC, right? Watching, like we still have to look at more details.
I think you're saying that we need to do the. I have something for the validate if it doesn't. The syntax is not correct or something. I will fill it in. Yeah, I will fill it first, and then I will do the loading or binding.
Yeah. I think this is mainly to validate whether this metadata is valid or not. Another thing is how, like, secure function. If Spark does not support that, then we had to fail fast. Things like that. I'm just mentioning like all this information detail where how do we support all kinds of feature within the UDF spec. Named function invocation. Sure, we have to support that. Default value Spark does not support that. How do we handle that? Things like that.
Yes, yes, we need yes, I try to do the. I mean, I know all the validation in the pre-validation method, but I don't have everything yet.
Thanks. Any questions?
No stuff. Sure.
All right.
Let us know when you want us to take a look at the PR, and we can start, reviewing and doing that. I don't know if now is the time since it's a proof of concept, but happy to help out there.
Sure. I still need more time to refine this. This is still a very hacky solution right now.
Sounds good.
Thank you for watching. Great demo. I think we have a bit of a better understanding of how spec works in the Spark list. Then we can go back to our spec discussion. Just give a brief introduction what happens in the last few weeks. So we have a discussion about whether we need a push down, have two sets of the parameter names, which we have the conclusion that we probably not because of named argument invocation. Then I made that change and in the specs. And another discussion is about nullable and the non-nullable return, which we have some agreement that it's going to be a hint. Some engines support that, some other does not. So we also made that change in the new spec, which is make that as a hint. And another thing, I haven't put a spec yet, but we discussed last time is about the default value and whether we want to support default value. And this is this feature, I think we have some consensus that, okay, we want to support that because Spark is like some other, like from engine side, Spark is trying to support that. And the Snowflake support that, maybe other engine also support that. One of the challenge I can mention, I'm coming to design is once we mark one argument with default value, we literally make that optional because you can say, okay, if you have two parameters, X, Y, and Y is the default value, Y has the default value, then you can invoke just to input as X. Then it becomes the a few implications. First is about the signature. When we have multiple overloads, then we have to deal signature that. Let me actually share my screen so that's discussion a little bit easier. Oh my God, I have to quit and reopen. Maybe later. So let me put it into the message. Let's say if we have F full int X int Y, then if we make the default value Y have the default value, then from caller side, there's could be ambiguity about this function and this function, which is this function, and any other type, basically any other types like float, string, Y, any other type. Right. Then how do I handle this ambiguity? Right now, when we design these overloads, we have come to a conclusion that we can use the type tuple, which is very simple and very effective. Means if you have two parameters, this is going to be the ID, and you can just check that without any problem, and there's no conflicts. And when we come to this, it doesn't work anymore, because when you have the default value for int y, literally you have to, when you create new overloads, you have to check the other overloads, see if there's any default value, and where conflicts with the existing one. So I just want to gather your thoughts on that. So my initial thoughts on this is it's not a big deal. Every time you have to do this, and you basically need a kind of algorithm. We can provide this algorithm in Java library. Say, okay, I'm gonna go through the other overloads and check their signature, see if there's any conflicts.
So I think if I could summarize what I think you're saying, is that if I have foo of int x, int y default 0, that actually occupies two signatures. Right. It occupies the tuple of int and the tuple of int. Right. So that makes total sense to me, right? Like you can only have one UDF that occupies a given signature tuple. And so if you define foo of int x, int y default 0, you cannot define foo of int x or foo of int x float y with a default.
Right.
Okay. I think that makes sense. That's a simple indexing operation, because you go through your definitions, you go through your parameters, and you basically say, okay, you know, int x, int y default 0 occupies int and int, and we're done. So I think that is a good idea. The only thing that I would push on here is what happens if I say, you know, define foo of int x after defining one that occupies int. Do we throw the exception in Iceberg? I suspect that we would, right?
Yeah. My thought is, first, there's two solutions. First, we allow this kind of overlap ambiguity, because if we allow that, sometimes might work, like any can select the exact match. For example, if you have food int and a food int y default, then engine will always, if you give just one parameter, it's like int, right? And you will always do the exact match. This is very dangerous behavior, but some engine might do that. But I look at the other engines, like nobody actually really wanted to allow this situation happen. Trino does not allow explicitly. Snowflake does not allow that. Wrong is fine. I mean, wrong is fine. It's just how do we, like, do we disallow this? I think we should, because that's the way to reduce, like, remove the ambiguity for across multiple functions. And how do we disallow that? I think from the specs, every time the engine or catalogs, whether any or catalogs create that function, we have to do the check. Unfortunately, it cannot be just the ID checking. It have to go through all these overloads to check.
So, Ron, actually, you mentioned about occupy two signature. I actually think this probably cannot work. For example, in the case like int x and int y default 0, if we created two versions, two definitions for this UDF, but the body will be the same.
So no, I'm not actually saying two definitions. I'm saying it prevents you from creating foo of x.
Oh, I see.
But not that we would actually change its ID. So I think the ID of int x, int y default 0 is still int. Then when we go and someone tries to create foo of x, we say, hey, there's already a function that gets called when I call foo of x.
I see.
Now,
So
yeah, like it's just like, yeah, do we disallow it or do we allow it and then engines can choose?
So if we allow it, that means we need to store additional information on other signature this definition also occupy.
I don't know that we need to necessarily store.
Okay, just.
I mean, we can say that this definition occupies these signatures and that you can only have one signature per thing. What we could also do is just have a signature that points to another signature or something like that, right? Like a definition that says, hey, the real definition is this other one. We could do that, but I don't know that that is a good idea, just because I think the library can handle these cases. I think it is best to only allow one definition. The only trouble is what happens when you have type promotion, right? So what if I have this foo of int x and y default 0, and I have foo of long? I guess that falls back to I have a more specific definition, and I should probably prefer the more specific definition.
Yeah, I like that.
Neither one is really more specific, right? But I think we would say that foo of xy is probably the right thing to use, because foo of long is a wider type. Okay.
Right. Depends on
Well, we will want to, I think, flush out some of these. Getting a prototype that supports this stuff is probably a really good idea, just because we will want to make sure that we have an implementation that has a deterministic way of choosing one of these functions before we move on.
Cool. I think we have some consensus where we don't allow this ambiguity when we within the spec. For example, every time it creates a function, you have to check in the overloads. Although ID check is not good enough right now, and we have to check the other overload signature, see if there's any conflicts between your current new function signature. Cool.
That's very reasonable though, because we do this for column resolution is a good example, where we take a schema, we index that schema by names, and then we produce something else. We don't allow ambiguity there. If you have dots in your names, we disallow that ambiguity, and I think that is simpler overall. And we also have this okay, so every time we parse this thing, we're going to grab all of the signatures for a given definition, and then generate the keys and stuff those into a map to reference the definition. I think that's a very good thing to do overall, and will work well.
That sounds great. I was trying to convert that into the ID part, but I failed to do so. I think the algorithm have to check all these overloads to decide whether there's any conflicts or not. Okay, let's move to next topic. I think
one more thought on this. When resolving by, so if we have multiple overloads, what happens when we're resolving by name? So I could have, I guess, if I have X, Y, Z, and Y and Z are defaulted, or all three are defaulted, right? So then I would have at least a tuple of, you know, no values X, XY, XYZ, right? So I would have all of those. But do I also have a tuple for XZ?
Yeah, we should have that as well.
Okay, and then so that would mean XZ, YZ, and Z.
It's all the combination.
The combinations.
But
Yeah,
if X, Y, Z all have the same type, then X, Y, or X, Z, or Y, Z, they're all the same.
It could conflict with itself, yes. But at least we have rules there, right? So if we know that you call foo that has these three and you provide one variable, we know that we know the definition that is responsible for this thing. And then we have rules for matching into the parameters. If you provide one parameter with no name, it's X. If you provide two parameters with no names, it's X and Y. And if you provide named parameters, we store those in the named parameters. So I think the only thing that matters is there's no ambiguity.
yeah,
That means we will not allow other overload definition with, let's say, just
Exactly.
one parameter or two parameter.
But I don't know about that. So let's say you had like three different types: int, float, string, right? If I have optional XYZ int, float, string, and I have an int string definition, I can tell the difference, right? Because if I say foo of 1A, then I'm clearly not like calling the definition that leaves out B. So I think that I could call foo of A, you know, X is 1 and Z is A.
Yeah, I think in this case, the initial one doesn't occupy the signature, right? We calculate the occupied signature, it doesn't occupy this one, doesn't occupy the first one. So if the type are different.
Yeah, so I think that we would probably keep things in order, right? So the signatures a given function occupies are basically the okay, so signatures would be based on position.
Yes. But
right? So I occupy signatures based on position. Then if you're calling by name, we could have a different resolution. I'm not sure what that means for like knocking one another out, but we would have to make sure that we do have. I think by position you can do it.
Yeah, by name it's problem. Let's say if we just have X and Z, let's say this three parameter X, Y, Z. If just have X and Z, then we can have ambiguity.
Yeah.
Because signature doesn't occupy, but by name resolution is a big problem.
Well, it could be a problem. We just need to figure out like what signatures you are occupied. Like it could just be that signatures are occupied and then because ideally what we would do is have one and only one way of doing this, and like use names to get positions and then use positions to identify the function. But I don't think we can do that in our version because each definition could have different names. In other words, I could have foo of XYZ and foo of XZ. And then if Y is optional, then those don't necessarily conflict on type, but they do conflict on name.
Yeah, it seems the default value and resolution by name, they're both are too flexible to be combined together. Those two together get to.
We just need to think about rules here. There's probably a way to do it.
by using default value, basically we allow the optional arguments, right? These optional arguments makes the signature much larger if we want to avoid ambiguity. I'm still think maybe the easiest way is to cover all these combination if you introduce one optional arguments, or the other, like combination of these, like if X, Y, Z all optional, then you don't allowed to have any function with 3 parameters, or less than 3, from 0 to 3. You are not allowed any type.
Well, but we would still have to allow it, because if you have one definition that's ints and another definition that's floats, like we would still want to support that type of overloading. It all just comes down to going through this in detail. I'm pretty sure there's something out there for solving the problem with names, but we should document the solution with positions, right? Because that is definitely a thing. With names, I mean, maybe what we do is, actually, here's what we can do. We can do the exact same trick with names, right? So we can do, rather than having types, we could do like XYZ, right, as a tuple. XY is a tuple, XZ is a tuple. And we could come up with all the name combinations that this thing occupies. So if you're calling by name, you go look up like, okay, here are the names that I have. You know, do I have functions that actually define those things with the names and the types that I'm talking about? I think we'd have to combine names and types at that point.
So let's say if I already have X, Y, Z, can I have a second overload of X and Z?
Not with the same types.
No, different type or similar, they're all different type, all X, Y, Z.
Yeah, right? Like, so if I have, if I have some function like this, I would want, okay, so say I have like a function that is, you know, default null, and it's a distance function in 1, 2, or 3 dimensions, right? I could have that distance function in a floating point, or I could have it in, you know, integers. Although integers would be weird because you're going to take a some form of square root, but I think that you could have function definitions with different types, but I think it would just be a matter of saying, okay, I have positional definitions or positional IDs, and I have by name IDs as well.
So my question is, if we have this and this coexist, let's say, they are different types, X, Y, XZ, and different type between these two overloads, right?
Mm-hmm.
When I just call this, which should be invoked?
So you probably can't do that. You can't have X default, Z default, because the first one already occupies the signature for no params.
Okay. So what are we saying is we can have X not default, Z not default, which is okay with different type.
Well, okay. So if they're different types, yes, you could do that. You could also do this.
But we have ambiguity when we resolve by name, right? If we have X equal to something or Z equal to something.
We're not, because you have type, check type.
No, X and Z, yeah, X, Y, Z, they all have different type. But you call full X equal to, but
I think what we
putting by
can
name.
do here, though, is figure out the specific rules. So we agree that like the base set of rules for position only means that XYZ occupies no params, one param, two params, and three params,
Agree.
the given types, right?
Yeah.
Then I think that this would also have a X with a type, Y with a type, Z with a type, and all sub combinations of that, right? So this would be XYZ, XY, X, YZ, or Z. Did I get all those? Right. Yeah, we would have all of those like different combinations. And then as long as you don't stomp on those combinations, then you're still okay. So if you have like Z is a different type, then it's perfectly fine, right? So if you have differentiation or enough information for us to detect something else, we could do that. And if you're loading by name, I think we would need to grab the names and the types that you're looking for and say, okay, do I have anything that is X is an int and Z is a string or whatever? And if I have something for it, then we load that definition and move on. So I think we can still do this as long as you have like rules around how to manage the exclusivity of signatures. The only thing is, this is making me a little uncomfortable in the definition of how we resolve names, right? Because I would love to have something very clean that is like the first parameter name is this, the third parameter name is this, and that way we can always map. It would be cleaner if we could always map and say, hey, this person's calling with a Z, and I know Z is always parameter 3. Being able to do that would mean all definitions have to use the same names. So we can either do the index with name and type, I think, or we could say everything is by position and names must always resolve to the same position, which is kind of what we've said with how these things evolve over time. Because if I have X and Y and I change the definition and change the SQL for that function, I still have to use X and Y. So maybe what we say is, this function always uses the same names.
That's what we already put in the spec, right? If we cannot change the name.
That's for overload.
Within a definition. But if we wanted to always say like, okay, I resolve names and then I resolve the function, we would need to have the same names across all definitions of the function. I'm kind of leaning towards that because that cleans up this problem in a fairly elegant way, which is like, why do you need to name things differently?
That's interesting. That means name signature is higher than the definition level because it's going to be top level signature for the name. If like on the top, we're going to say, if you're going to introduce a new name, this is set of new name XYZ. There's no other way to, like, at least like we don't have to say that, but at least you have to follow. If already have the overloads, this is XYZ, you cannot pick up another name for the Z.
Yeah, which is a little awkward, but does allow us this property of always mapping names. It's also, I think, does this simplify everything in general?
I think it simplifies things when you have multiple overloads. So within the function, and you wanna use named arguments invocation. That's significantly simplify that. I still have to think about how does it help with the default value.
I mean, the nice thing is you would be able to have essentially the we could always take the signature of the definitions and collapse them into a single set of names and what is optional. So like we could always say you can call this with X, Y, and Z. X, Y, and Z are all optional. Which is kind of nice, right? Like you wouldn't necessarily need to you wouldn't need to look up and resolve a definition in order to say what is, you know, potential here. We could also go over all of the, I mean, essentially what we're saying is you take every definition, you take its types, right? And then you get this sort of list. So X could be an int or a float, Y could be a string, and Y is, you know, optional. Now you don't necessarily have all those combinations, right? So you might have foo of int string and foo of float, but not both. But I think I might like that in terms of simplicity for users. We need to think about this, I think, specifically. We can do it either way. I'm confident we can do it by indexing, but we should consider whether we want to just be more strict.
Cool. I think I can take a close look about that idea. I think that I'm kind of leaning towards the unified name resolution. It looks like better user experience for a user. Like when you invoke the function, you always have that name list to invoke, and potentially it will benefit how we pick up one of the overloads to invoke.
Does that mean we need to add the name to the signature or to the
yeah, it's part of signature. I
This
think
reopens last time's discussion as well, because if you have a definition with names and then they're in the definition, like we could just have global names that always override. And if you have global names, then that's actually kind of a nice thing. And you get like whatever global name you had, you can rename a particular thing, but all of the definitions are insulated because they have their own names. Just to make this harder. Yeah, but I think I am also leaning toward global names. That way you always get consistent names, and it's not like, you know, describe function, for example. When I'm looking at the definition for this function, how do I show what names are there, right? So if I have foo of AB and foo of XYZ, like that makes itself harder. That itself makes it harder for users to call this function, because a user trying to use named parameters, which is, you know, something we want to support, doesn't know whether to use A for the first one or X for the first one. And we would be saying, essentially, if you call this with a named function, named parameter A, then we are never going to match the X, right? Even if you really meant, oh, this is the first parameter, because you looked at the definition and A was the first parameter. So I'm kind of leaning towards global names here.
Yeah, I think so. I agree. The only problem is like, how do we, like, I mean, so from spec perspective, how do we like promote that global name? we still spread them into the multiple overloads, or we put on the top level every time we register new names with one overloads, right?
I think we would probably union the set of names every single time that we produce this. And that would mean that you need a list of names at the top level above definitions, a list of names for parameters, but probably a list of names and docs, right? So we should, this is, if we're splitting out the names from definitions, we should also split out docs so that docs for any parameter are consistent across all calls.
Yeah, that makes sense. I think that makes sense. So if I get it right, do we still have two sets of names for representations and a global level? So that, I mean, we have this discussion last time, and we thought, okay, this kind of a mapping, like each and you have to do the mapping every time they invoke that function, so that have a little bit burden.
I think this is where it would be really good to have an idea of how hard it is to, like, what does actually injecting this stuff look like when we are doing this? Because like what we're saying, what we said last time was really hard about having two sets of names was, first of all, doing the position mapping, like the name to position mapping, and then swapping out those names when resolving. But what we're saying now is the name to position mapping is already going to be separate, right? That is a phase that you go through before selecting your definition, which I like quite a bit. I think that's a good idea in general. So we do name to position mapping, then we select a definition, and then the definition just says, hey, I have X and Y, and here's the thing, or I have A and B, here's the definition, the SQL. I think that if we're doing it in those separate stages, it's not too bad. Because we were still thinking last time that what you would have to do is select your definition, then do your name resolution, and then change the names. Whereas if all you're saying is, you know, here is my struct of, you know, here's how this thing was called, give me a definition, and definition is the only way you get those names, then I think that's okay.
Yeah, I think we still have to, yeah, I mean, first set is naming invocation where people would just give the name, right? Then we select definition. Maybe that's fine, but still on this definition level or representation level, we still have to swap out these individual names, do the mapping by position first, and then swap out this name. Maybe that's fine. We can look at the detail. Like I can take a look at the implementation side.
I mean, cool. I'm kind of like, if we have two phases anyway for resolution, then I would probably say, like, let's do the installation, and each definition carries its own names.
But the doc was
held.
Okay, doc was still on the top level, right?
Yeah, and I like that. Like, you have a high level schema that is essentially name, whether it's required or optional, and whether it has a doc.
Sounds good. Thanks. Yeah. Another topic is about if we have default value, right? We want to support that. What if engine does not support default value? We allow engine to ignore this default value, or it should just fail? Because the engine still, if they ignore the default value, they can still provide all these input. Let's say if there's X, Y, Z, or by default they just provide all inputs.
It's up to the engine. Yeah, I mean, it should be easy for the engine because really, like, a default value is just looking at this definition and saying, okay, for my input to this function, one of my inputs is a constant. But I agree.
Okay. So yeah, next one is actually I feel a little bit hard to, how do we give the default value for the complex type? For simple type, it's very simple, just a literary aspect literary with the string, like JSON representation. And for the complex one, map, list, structure, like how do we have to give all these value in the subfield when we provide this default value?
So I believe where we're at with default values in Iceberg is we said it's going to be a whole lot easier if we don't do default values at the struct level that differ from the default values at the actual like default values for each field. So at least a struct is either null, like the whole thing is null and your default value is null for that struct, or the default the struct is non-null and your default values are all field level defaults. So that is much simpler for handling structs. We do not currently, like, I don't think that we currently support default values for lists and maps. I think it would be reasonable to have a like flag that is identical to this, that says like whether a default is, you know, an empty map or an empty list or not. And I think that that's where we're at with the spec on the table side. I would need to double check that, but I think that that's where we're at. And I think that that would work here as well to simplify, because we usually don't want, well, I mean, you can always come up with cases where you have a default mapping or your custom mapping or something like that. But
yeah, so for the structs, subfield value will be kind of a struct definition provided by itself, right? If this struct definition has these like the certain default value for its subfield, then we just take that and we from the top level we don't care, it's a none or none.
Exactly, because what we decided on table, you know, column defaults was that it is confusing. First of all, this is a two-way door, right? Like we can always introduce struct level defaults that differ from field level defaults, but we probably don't ever want to. And it's confusing for users to like have a struct level default that's, so like how did they know to, how do you express like, I want to change the default for this field in this struct? Do you have to like, you know, replace the entire struct level default? That doesn't really make sense. So and setting the default value for a struct anyway gets you in this position where you have to inherit defaults for new fields, or you have to update the default for a struct. So it's a whole mess unless you just say field defaults are defaults. Now that the trick is that requires all fields to be defaulted in order to be able to default the struct.
Yeah, it's not quite expressive, right? In that way, you give a default, but it basically means that's whatever you definition it is.
But I think that is the most reasonable path forward with struct level defaults, is to say like it's field level defaults. If any field is required and missing a default, you blow up. Otherwise, if it's optional and then your default is null. If it has a default, you use that default. Like I think it's a very reasonable path forward.
Agree. I think we can just start from there. Thank you very much. We out of time. Thanks to everyone. I'll send out the memo a little bit later. Thanks. See you
Thanks.
next time.
Bye, guys.
Bye.